Welcome to Smart TECHI. In this episode, let us have a discussion on centroid of composite areas with the help of a numerical example. So, in many engineering applications, we use composite areas. So, it is necessary to find the centroid of such composite areas. Some of the examples are I section, C section, T sections, etc. There are many other examples. So, usually what we will do is, we will divide the composite area into a number of simple areas like rectangle, triangle, semicircle, etc., for which the areas and location of centroid of the areas are known. So, the general expression for the distance of centroid of a composite area from y axis is given by the expression x bar is equal to integral x a divided by integral a. So, which is equal to sigma x a divided by sigma a, which can be expanded as a1 x1 plus a2 x2 plus etc. divided by a1 plus a2 plus etc., where a1, a2 etc. are the simple areas that we have identified from the composite areas, and x1, x2 etc. are the distance of centroid of a1, a2 etc. from the y axis. So, similarly, y bar is equal to integral ya divided by integral a, that is equal to a1 y1 plus a2 y2 plus etc. divided by a1 plus a2 plus etc., where a1 a2 are same, the area of the subsections, and y1 y2 etc. are the distance of centroid of each area from the x axis. So, this will become clear when we do a problem. So, let us solve a T section for finding its centroid. So, let us do a numerical example. The question is to locate the centroid of the T section shown in the figure. So, this is the given figure. So, these are the dimensions. The flange width is 200 mm, depth is 20 mm, the web section depth is 300 mm and width or thickness is 20 mm. So, this is definitely a composite section. Why? Because we can divide it into sub areas. When we get a composite section, the very first step to find the centroid is to identify the sub areas. So, here we can find two sub areas, isn't it? We can easily divide this T section into two rectangular shapes. So, let us name them as 1 and 2. The second step is to locate a reference coordinate system. Why? Because we are going to find the centroid of this T section. That is, we are going to find a point. How will we find a point? What will be our answer? Our answer will be the coordinates of this point, that is x bar and y bar. So for defining a point as coordinates, we need a reference coordinate system. So that is why the second step is necessary. So when we establish a reference system, that is an x-axis and y-axis, we should proceed like this. That is, if this figure has an axis of symmetry, then definitely this reference axis should pass through that axis of symmetry. So in this T section, we can divide the T section into two symmetrical halves along this vertical axis. So let us choose this vertical axis as the y-axis. So I will draw the y-axis here. Now we need an x-axis. So for convenience, let us take the x-axis along the bottommost portion of this T section. So let this be the x-axis. Now, as we have told earlier, since this section is having an axis of symmetry along the y-axis, definitely the centroid of this figure will lie on that axis of symmetry. We don't know the exact position, but the centroid will lie somewhere on the y-axis. So we can easily say one thing, that is, since the centroid is on the y-axis, the x coordinate of the centroid will be 0, or we can say that the x bar will be 0. So one part of the problem is already solved. That is why we took the y-axis along the axis of symmetry. We could have taken y-axis along this side, but we purposefully took the y-axis along the axis of symmetry so that we can easily fix x bar as 0. So the next step is to find y bar. So for finding y bar, we have the general expression y bar is equal to a1y1 plus a2y2 divided by a1 plus a2, isn't it? Because there are two sub areas, so a1y1 plus a2y2 divided by a1 plus a2. So now we will find the values of all these terms. What is A1? A1 is the area of first figure. So the first figure here is this rectangle, the area of which is 200 multiplied by 20, that is equal to 6000 mm square. Then what is A2? A2 is the area of the second rectangle, that is equal to, this is 4000 mm square. So A2 is the area of second rectangle, that is equal to 300 multiplied by 20, that is equal to 6000 mm square. Now y1. What is y1? Y1 is the distance from the centroid of the first figure to the x-axis. Y1 is the distance from the centroid of the first figure to the x-axis. So for that, we need to locate the centroid of the first figure. So where will be the centroid of the first figure? We know that the first figure is a rectangle. So the centroid will be at the geometric center of this rectangle, that is If this is 10 mm, then this will be the centroid of the first rectangle. Let us mark it as G1. So we have to find the distance from G1 to x-axis. So y1 will be equal to, we know that till here the distance is 300 plus half of 20, that is 10 mm. So y1 is equal to 300 plus 20 divided by 2, that is equal to 310 mm. So similarly we have to find y2. What is y2? y2 is the distance from the centroid of second figure to the x-axis. So the centroid of the second figure will be exactly at the center of this rectangle. So this is 150. Centroid of the second rectangle will be at exactly this point. So y2 is equal to 150 mm. So now we can directly apply these values to this expression to get the value of y bar. So y bar is equal to A1, that is 4000 multiplied by y1 plus A2, that is 6000 multiplied by y2 divided by A1 plus A2. So the value will be 214 mm. So how will you mark this value on this figure? So y bar is the distance from the x-axis to the centroid. So from x-axis the centroid is at a distance 214 mm. Where here approximately we can tell that somewhere here. So this will be the centroid of the T section. This distance will be equal to y bar, that is equal to 214 mm. So we can say that G centroid is located at 0, 214. So this is the answer. So I will repeat the entire procedure once more. First we identified the sub areas in this T section and we named it as 1 and 2. Then we chose a reference coordinate system x and y. We choose the y axis such that it divides the T section into two symmetrical halves, or we choose the y axis along the axis of symmetry and x axis along the base. Then we wrote the expression for y bar. We know that x bar will be equal to 0. Why? Because the centroid of a figure will lie on its axis of symmetry. So the axis of symmetry is y axis. Centroid will be a point on the y axis. So x bar will be equal to 0. So to find y bar, expression is y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2, where a1 is the area of first figure, y1 is the distance from the centroid of the first figure to the x-axis, a2 is the area of the second figure, y2 is the distance from the centroid of the second figure to the x-axis. So we find out the numerical values and substituted in the expression to get the value of y bar. So y bar, so the centroid of the T section is at a distance 214 mm from the x-axis. and it lies on the y-axis. Hope you understood the topic. If you like the video, please share among your friends and subscribe to our channel for more similar videos.